Motion is by far the one that students struggle with the most. So let's take a look at how we might set this up. Up to this point, we have used X and Y pretty much all of the time. Here, it might be helpful to say that P is the plane speed and that W is the wind speed. That will help us. The other thing we need to know here is that distance equals rate times time. So let's see how we can put all of that together to help us write an equation. So a plane is flying 660 miles from Atlanta to Miami, 1.2 hours, which of course is going to be a time, when traveling with a tailwind. So the plane speed would be assisted by the wind speed. So this first equation would be 660 miles, the distance of 660 miles equals the rate of the plane speed plus the wind speed. That's my rate, is adding the plane speed in still air and the speed of the wind because it's with the tailwind, and the time is 1.2 hours. On the return flight, which is still 660 miles, I am going against the wind, which means the plane is being slowed down by the speed of the wind, and of course that takes a little bit longer. Now, what most people want to do on this question is to distribute the 1.2 or distribute the 1.5, or horrible, they try to add the equation just as it is. Don't ever try to add the equations when you have the parentheses in there. And in this case, it's actually easier, instead of distributing the 1.2 and then trying to isolate a variable or solve by substitution or elimination, I'm actually going to divide this whole side by 1.2 and divide this whole side by 1.2, because the 1.2 on the right will cancel, and that will just leave me with P plus W. On the left, 660 divided by 1.2 gives me 550. Using that same process, dividing by 1.5 on each side for the second equation, the 1.5's cancel, leaving me with P minus W on the right. On the left, I get 440. Now, this is set up very well to use elimination without a whole lot of work, because obviously adding these together, I get 990. P plus P is 2P, but W plus negative W cancels. And so now I can solve to find P very easily. So P is 495. 495 is P, which is of course the plane speed in still air. To find W, the wind speed, I'm going to use any of these equations. I'm going to choose to use this equation because it's the easiest. So 550 equals 495, which is P, plus W. Subtracting 495, I get 55 equals W, which means the speed of the plane in still air is 495 miles per hour, and the speed of the wind is 55 miles per hour. A similar question for you to try. So press pause, try the question, then press play to check your work. So just like last time, P will represent the plane speed, and W will represent the wind speed. The plane is flying 450 miles. Again, distance equals rate times time. So on the way there, distance is 450. Rate would be the plane and the wind. So it's with the wind, meaning the wind is assisting. P plus W times the time of 3 hours. Flying back against the wind, it takes 5 hours. So again, same distance. Rate is P minus W, and time is 5 hours. And I'm going to solve it the exact same way. So I'm going to start by dividing by 3 on each side on my first equation, which gives me 150 equals P plus W, because these 3's cancel. On this one, I will divide by 5, which of course gives me 90 equals P minus W. Adding those together just as they are, 150 plus 90 is 240. That gives me 2P, and my W's cancel, so P is 120. meaning the plane is going 120 miles per hour. And then the wind, I would find, again, this is the easiest one. So 150 equals 120 plus W. Subtracting the 120, I get 30 equals W, which means the plane is flying 120 miles per hour and the wind is blowing at 30 miles per hour.